Hopefully you've had a chance to try the practice problems 7 and 8. I'm going to walk through their solution now. So looking at this, I've already drawn the Lewis structures in 3 dimensions. Here, let me actually make it in 3 dimensions to kind of speed this process up. Um, and what we're looking at is which of these molecules contains the strongest bond. So what I'm going to look at when comparing these is really the shortest bond, right? And I'm looking at carbon and hydrogen and nitrogen and oxygen. And these are all, except for hydrogen, on the carbon, nitrogen, oxygen are all in the same second period. Hydrogen's on the first. So there isn't a large difference about where they fall on the periodic table, thinking about the period that they're in. However, the thing that jumps out to me is that I have a carbon-carbon double bond and I have a carbon-nitrogen triple bond. And so that piece right there, more than anything else, speaks to the strength of these bonds. So the number of shared electrons is going to bring the distance between those nuclei closer together more than anything else other than size down a period. And so when we're comparing things on the same period, that number of bonds between things will play the largest role in determining strength. And so that triple bond is going to bring it closer together. So the strongest bond that we have here is this CN triple bond. So I would say the C2H3N contains the strongest bond. So here we're looking at the chlorides again, and we've already seen a pattern for these lithium, cesium, sodium, potassium, that the size is going to go lithium at the smallest, then sodium, then potassium, and then cesium. And so our size is increasing. I'll put these for our charges too. And so which ionic solid is likely to have the smallest exothermic lattice energy? So which will release the least energy? When the lattice forms. So the compound that's going to release the least amount of energy is going to be the one with the weakest ionic bond. And that's really going to be dictated by size because all of our charges are the same. These are all +1 ions. Now, if one was a +3 and one was a +2 and one was a +1, I'd say that +1 is going to be the weakest. But because these are all the same charge, I'm going to say the largest is the weakest. So I'm going to go ahead and say that my cesium chloride is going to have the weakest bond, or the least energy released as the lattice forms, so the smallest exothermic lattice energy.